Okay, so let's start off stats 119 spring semester. Okay, in statistics, you hear things about statistics. You hear on the news, you'll hear statistical reports, and you'll hear the CDC is putting out statistical information, and sometimes you don't know what to think about it. My favorite example of statistics is during elections. Okay, here's a really simple one. You will hear about polls. Everybody knows what a poll is. A poll is when you ask people who you're going to vote for, or what do you think of this proposition. And they'll report information. This percentage of the people feel this way, or this percentage of the people are going to vote for this candidate. And everybody should have the same feeling generally. You're saying, how did they come to that conclusion? They didn't ask me, right? You guys have had that feeling before? So how in the world can we say something if it hasn't happened? How in the world, for example, if you're a gambler, how in the world do you know what are the chances that you're going to win? Okay, this is the probability side of things. We do things. There's so much out there. You're saying, well, how could anybody know this? Well, it turns out the mathematics of statistics is pretty powerful in making these kind of things, making these kind of conclusions. In the example of the polls, we're going to do a lot of that later on in the course. If it's done right, you actually can trust the outcome without asking everybody. Okay, so let's start with some very simple terms. So the first one, I'm going to write the terms down and then I'm going to state them. And I'm going to show you where you can find a lot of the information if you don't want to write it down yourself. So the first one is the word data. Now, data is just the collection of stuff. For example, if I wanted to know, let's say, how many children everybody has. Okay, and so some of you would say 0, some of you might say 1, some might say 4, some might say 3. So I'm going to collect these numbers, okay, that represent everybody in the class. I might say, how many units are you carrying this semester? Or the data might just be, do you identify as male or do you identify as female, and just simply count how many people. This is all called data. It's just simply the collection of stuff that I'm observing. That's it. Now, I have to have the data to make any kind of conclusion or any kind of calculation, but the data is just the stuff, the collection of the numbers or the information. The data might be, who did you vote for last election, right? That could be data. Now, statistics as a whole. Now, what statistics is really, it's just basically the idea of I'm collecting data and I'm going to make conclusions based on the data. I don't have to collect all the data. I want to make a conclusion about basically people in the United States, right? We have 330 or 340 million people in the United States. I want to make a conclusion about all people in the United States. It might not be reasonable for me to ask everybody or for me to measure everybody. So the statistics is I'm going to try to make a conclusion based on some gathering of information, and it might be what's called a sample. We'll go over that in just a moment. Now, population. The population is what it is you're measuring. And if my population might be, let's say, I'm looking at pets in San Diego County. The population would be all of the pets in San Diego County, right? Dogs, cats, birds, everything. Population would be every single thing that you're studying within the confines. Could be animals in California. It could be people in the United States. When you hear the word population, people always think of people. Well, don't think of people, but think of everything you're collecting. So I might just be talking about Mesa College. So my population might be all students at Mesa College, or all employees at Mesa College, or all people on campus at Mesa College. That would be an example of a population. So a population is every single item that you're studying. It doesn't have to be people. Okay. Next, census. I think we're all familiar with a census. Every 10 years in California, we collect information about every single resident in California. Now, census is one of the rare times where we actually, we don't ask some people, we ask everybody. So if anybody here's ever filled out a census before, they'll mail a series of questions to every household in the state. And you fill out questions like how many people live here, how many people are over a certain age, how many people are under a certain age, how many men, how many women, how many cars. They'll ask you all sorts of questions and they'll collect all the information. So a census is one of the only times statistically where we actually try to get every single value that can possibly be there. Because if we're going to make conclusions about the state, like for example, what is the percentage of people in California over the age of 65? How would we know that unless we know every single person in California? Or in California, what is the percentage of households that have at least 2 cars? Information like that. It's fairly simple. Now, probably the most important thing we're going to do in this class is the concept of a sample. A sample is a collection of information, a collection of data, but it's not the whole. The census would be the whole, the sample would be the partial. So the sample would be like the polling questions at an election. I'm going to ask a handful of people who you're going to vote for. That's my sample. Okay, or I'm working in a chemistry lab and I want to take a sample of the stuff I'm looking at, whatever the substance is. I'm not going to use all of it. I'm going to take a portion of it and then I'm going to analyze it. So what we do is we make conclusions based on samples. So on Thursday, we're going to talk about how do you actually collect samples. Is there a way of doing sampling that's very, very accurate, or are there ways of doing sampling that is very inaccurate? I'm going to give you a really simple example. I would like to find the average height, let's say, of the people in this class. Well, they said that's a pretty easy thing. It's not a huge group, so we'll just measure everybody in the class. But what if I said, no, I'm just going to take 3 of you and we'll use that to measure the people in the class. We'll just take any 3 of you, we'll find your average height and we'll use that to represent the group. I mean, we could do that. So rather than measure your height, I'm going to ask all of you how tall you are. I'm going to ask all of you how much you weigh. I'm going to ask all of you how old you are. Is it possible I might not get accurate results, folks? You can say yes or no. If I ask you these questions, I'm not going to measure you. I'm just going to ask you. Especially if I ask how heavy you are. Now, am I going to get truthful, accurate information? Probably. Just so you know, my driver's license says 5'10". It's always said 5'10". And I think I reached, like, at one point in my life, I was like 5'9 3/4. Yeah, I've gotten shorter over the years, but my license says 5'10" because when I filled out my DMV form, I got to put down my height. See, if I get to put down my height and weight, I might not be accurate. I might put down the height and weight that I would really like to be, not necessarily the height and weight I am. So is it possible we could have incorrect information in certain situations? Yeah, obviously, if you get to put down what you want to put down, so if it was a weight question and you didn't like your weight, you might put down something a little bit less. Or if it's a height question and you feel short, you might go a little bit taller. So there are certain situations where you could say, yeah, it might not be that accurate. We need to do this correctly. Okay, so let's start with this. I've got here's my reason. Now, the next group of questions, or the group of terminologies, I've got these kind of sectioned off. All right, now, these two go together. Parameter and statistic. Now, let's keep it really simple. My favorite example to use, and I will use the same example all throughout the course. I would like to find the average height of a Mesa College student. Now, in most semesters, we're in the upper 20,000s, like 27, 28, 29,000 students. Right now, we're down a bit. I think we're closer to about 20,000. Okay, but I would like to find the average height of a Mesa College student. As you probably gather, it would be very difficult to measure every single Mesa College student. But maybe it's because I want to form my own clothing line, let's say, and I want to market it to Mesa College students, or I want to open my own restaurant on campus and market it to Mesa College students. I want some information about Mesa College students so I can make good choices from a business standpoint. Parameter would be the average height of a Mesa College student. A parameter is a number that is a measure of an entire population. And if my population is Mesa College students, and I can collect information about every single student, then I have enough information to say, this is the average height of a Mesa student. Now understand, we actually have a database with every Mesa College student, so we know things like everybody's age, we know how many units everybody is taking, we know things like that, but we might not have detailed information. For example, we might not know, for example, how many children everybody has, or how many siblings everybody has, or how much money everybody earns. These are not questions you may have filled out. So a parameter is a number or a measurement of an entire population. The census, remember, we collected data on every single person, so we can give population information. But in real life, it is unusual to try to collect information of every single thing in the population. So what we do is we do samples. We collect some information, and the numbers that we get based on the sum information, those are called statistics. A statistic is a number from a sample. Parameter is a number from a population. And rarely will we have the ability to actually collect an entire population. Just that's really what it comes down to. If I wanted to, let's say, measure the amount of salt in ocean water, here's a perfect example. This is something you might have done in a bio or even a chemistry class. I would like to measure the amount of salt. You know, it's 5%, 10% salt, whatever. Am I going to go out there and measure all of the water in the oceans on planet Earth? Probably not. That might take, an infinite amount of time. So what are we going to do? We're going to collect some water from the ocean, maybe several gallons, and then we're going to measure the amount of salt. I don't think it's reasonable to think we can measure all of the salt in the entire oceans. There's a lot of water out there. So the parameter would be all of the water in the oceans. The statistic would be the amount in the sample we collected. And a sample would make perfect sense, because if I'm sampling at random, we'd think the water around it is probably pretty similar in terms of the salt content. Okay, so population value, sample value. Okay, and both of these would have to do with calculations usually. Now let's do an example of that. Okay, so it might be something like this. You want to know how many dogs, let's say pets, not stray dogs, how many dogs are actually pets registered in San Diego County. So you could find out, okay, the number of dogs in San Diego County that are licensed, probably have their tags and so on. We could probably find out this information. We could go to a place. I don't want to say we'd go to the pound, wherever it is you'd register your dog. So if I said, how many dogs are there in San Diego County? Okay, registered, that would be a parameter. If I said, I would like to know what is the average number of dogs therefore San Diegans have. Well, I would just take the number of dogs that we have and divided by the number of people. So let's say that on average, there's 1.5 dogs per person in San Diego. I don't think it'd be that. Now, what if I said the number of dogs on my street? Would this be a parameter? No, this would be a statistic. No. Because why? Why would this not be a parameter?
It's a sample.
Yeah, it's only some of the dogs. It's not all of the dogs. And could I use this information to help me try to come up with that information? Let's say my street has a lot of people. And I said, well, gee, on my street, everybody, there's a dog for everybody in here. So I'm going to speculate that San Diego County. I could do that. It might not be very accurate, but that would be a statistic. That would be a parameter. So if it's the whole population and you actually have the information, and by the way, you very well may have the information, okay? Sample versus parameter, it's usually going to be pretty obvious which it is, because you know the difference between the whole population and a small collection. Now, The last word I want to go over before we take a short break. The last two, when we're looking at data, okay, here's an example I love to use. All right, when you are voting, give you a perfect example. When you're voting and you're going to the ballot box, let's say there's a lot of candidates for whatever it is you're voting for. They're usually going to be numbered 1, 2, 3, 4, 5, 6. And let's say you voted for candidate number 6, and somebody else voted for candidate number 3, and somebody else voted for candidate number 1, and so on. Well, I think we all know the winner is the person that gets the most votes. That's really not a question. What if I said to you, okay, here's what's going to go on. We're gonna ask a group of people how many offspring they have, how many children they have. And the numbers we got was 1, 1, 0, 3, 4, 2, 1, 2, 3, 4, 5, 6, 3, 1. Make sure I want to get 10 on here to make it easy. 5 and 2. We have a group of people and we ask them how many children each of them have. And these are the numbers we come up with. Could we find the average number of children of this group? Yeah, we're not even talking about calculations, but I think all of us could figure this out. I would add them up. 1 plus 1, that's 2, plus 3, that'd be 5, 9, 11, 14, 15, 20, 22. There are 10 people. So I believe we would come up with, I have a group of 10 people, there's 2.2 children per person. Is everybody okay with that? That makes perfect sense. Okay, now we're going to vote on something. We're going to vote. Maybe we're picking a president of our club or something. And there are 5 candidates. There are 5 candidates. Now, this person, I didn't vote for anybody. I didn't like any of the candidates. So my 0 means I didn't vote for anybody. So I voted for candidate 1, I voted for candidate 1, didn't vote for anybody, candidate 3, candidate 4, candidate 2, candidate 3, candidate 1, candidate 5, candidate 2. So do we say candidate 2.21? Think about that. Do I average these numbers together? Think about that for a moment, folks. I'm voting, so the names are listed. There were 5 names. Candidate 1, candidate 1. I didn't vote for anybody. It's okay not to vote for anybody. 3, 4. Well, how should I select a winner? Shouldn't it be the person that got the most votes? Do you all agree that the person who got the most votes should win? Well, who got the most votes? I think candidate 1 got 3 votes. Candidate 3 got 2 votes. Candidate 2 got 2 votes. Candidates 4 and 5 only got 1 vote. So I think the winner would be the one who got the most votes. But these are numbers, aren't I supposed to average them together? They're not numbers in that sense. It's just candidate 1, candidate 2, candidate 3. So there's 2 types that you could always put data into. Okay. In the case where these are children, these are actually counts. That's called quantitative. Quantitative, that means it's numerical in nature. Like, how many children do you have? How much money did you make last year? There's a number there that has meaning. I can add it to other numbers. I can find averages, things of that nature. If I said, who did you vote for? There's no numerical value with who you voted for. If I said, what's your favorite color? If I asked as a group what your favorite color was, and I gave you choices. So in other words, I don't want an infinite number of possibilities. Maybe I keep it simple. It says, okay, you've got blue, yellow, and red. What's your favorite? I don't think we're going to put the paint cans together, mix them together and say, this is the group's favorite color, some mixture of all the colors. No, it just, which color was the most popular, red, blue, or yellow. So quantitative is numerical in nature. How many children did you have? But what if I just want to talk about who did you vote for? What's your favorite color? What's your favorite place to go on vacation? There's no numerical value there. That's called qualitative, or sometimes it's called categorical. Numerical, descriptive. Quantitative, like quantity. Qualitative, like you can even think quality. I'm describing something. When you're giving a description, that's not a number. If I said, gee, what, were you happy with your vacation? Yes. No. I have yeses and I have nos. There's no numbers there. There's nothing for me to count or to average or to add together. So this one's actually a fairly simple one to think about. Now, let me ask you a couple questions, okay? This is one of the examples I loved using. Okay, I'm a big sports guy. All right, LeBron James scored 30 points last night. Would that be quantitative or qualitative? Blurt it out. What do you think?
Quantitative.
Quantitative, no question. LeBron James' number on his jersey, I believe, is 23. The number on LeBron James' jersey is 23. Is that quantitative or qualitative?
Qualitative.
Yeah, because the number on his jersey has no numerical value. It's a way of identifying him versus the guy who wears number 10 or number 14 or number 20. Ah, okay. You just spent, let's say, $2,350 on an appliance. Quantitative or qualitative? $2,350 on an appliance. Quantitative or qualitative?
Quantitative.
Yeah, that's kind of easy. You live at 2350 Genesee. I think I'm spelling that correctly. Your address is, okay, you spent $2,350 on an appliance. You live at 2350 Genesee. Quantitative or qualitative?
Qualitative.
Qualitative. It literally is describing the name of where you live. Does this number on your street address have any numerical value? The person across from me on my street is one number different from me. They're one digit different. Does that mean that they're one ahead of me in some capacity, or they have one more than me, and the person on this side of me has a smaller number, but the person on this side has a bigger number? Do those numbers mean anything numerically? No, it's just describing that's my house, that's their house. So you kind of got it. This is a value that has meaning. This is just describing where I live. That doesn't have any meaning in terms of a number. Okay. Now, what I want to do is take a short break because we've been going a little bit of time. Break, I mean like 5 to 10 minutes. We're going to do this because I don't think anybody can go through Zoom for 2 hours plus, and it's too much. I'll tell you why when we come back, because I do a lot of Zooming. So let's take a short break for right now.